Hello, students. Welcome to this lesson with Mrs. Tega Festus. Hope you enjoyed the last video. In this lesson, we'll be talking about force. In all activities, you need to make contact with objects, either by pulling or pushing. When you push on a hard object like a table or a block of wood up a slope, you feel the effect on your arm muscles. Also, when you push an object or pull an object upward, the object covers a certain distance. A magnetic object is attracted by a magnet with or without making contact with the object. In other words, whenever we push, pull, or raise an object, a force is applied. Also, a force can be felt with or without making contact. Therefore, force is defined as any action that tends to change the position of a body or its motion in a given direction. Force is any agent that causes change to the state of rest or change to the speed of an object. This brings us to calculation on force. The formula for force is equal to mass times acceleration due to gravity. The SI unit of force is Newton. What force is required to accelerate an object with mass of 20 kg from stationary to 3 meters per second? Let's see how this calculation is going to go. So, solution. Force, as we all know, is mass times acceleration due to gravity. And we are given mass as 20 kg. Acceleration due to gravity is 3 meters per second squared. Force now is equal to mass times acceleration. Mass, which is 20, times 3, which is acceleration, that answer gives you 60 Newton. Remember, your answer must always end in Newton. Types of force. There are two types of force. Number one is the contact force and the non-contact force. So that brings us to explaining contact force. A contact force is any force that requires contact to occur. In other words, a contact force requires physical contact between the force and the object that the force will affect. These are forces that are in contact with objects they affect. This contact may be direct or indirect. But the most important thing for you to note is that for contact force to occur, there have to be a physical contact between the force and the object it's going to affect. So that brings us to examples of contact force. We have the push, the pull, tension. To create tension means to stretch or strain an object. It could be elastic, it could be an elastic object. Then we have the twist. For example, like twisting your clothes to get water off. Then gripping, to use your hand to hold an object firmly. You can see your hand and the object comes in contact directly. That's why it is called contact force. So this brings us to non-contact force. A non-contact force is a force which acts on an object without coming physically in contact with the object. These forces do not require contact with the object in which they are acting on. They usually have a force field. So that brings us to what is a force field? A force field is that area, region, or space within which the effect of force is felt. Examples of non-contact force. We have gravitational force, magnetic force, electrical force, and electromagnetic force. Gravitational force was discovered by Isaac Newton. That's the picture of Isaac Newton. This is the force with which the earth pulls objects towards its center. This is the reason why when you throw an object up, it comes down. Every object above the earth's surface will always fall back to the center of the earth. So it is that force that attracts objects to the center of the earth. The space that surrounds the earth with which the force exists is called a gravitational force field. Work is done against gravity whenever an object is lifted upwards. Formula for work done against gravity is force times distance, which would also be height. Or work done is equal to mass times gravity times height. Then this brings us to calculations on work done against gravity. If a load of mass 12 kg is raised up to a height of 40 meters, what is the work done in the process? Solution. Work done is equal to X. Remember, we're looking for work done. Mass we are given as 12 kg. Gravity is given to us as 10 meters per second squared. Height is given to us as 40 meters. Work done is equal to mass times gravity times height. So what would that be? That would be 12 times 10 times 40, which is 12 times 10, 120 times 40, 480 joules. Work done always ends in joules. The answer for work done must end in joules. So that brings us to magnetic force. A magnetic force is a force exerted between magnetic poles, which causes the opposite end of the magnet to attract and same ends of the magnet to repel. What will mean opposite end of the magnet will mean north and south poles. They will naturally attract. North and north poles will naturally repel. Magnets are materials which are capable of bringing iron objects to itself. Iron objects will naturally be attracted to magnets. A magnet will only magnet iron, not plastic. So the region or space that allows magnetic force to be felt is called a magnetic force field. That brings us to electrical force. This is a force experienced within an area of an electric charge. There are two types of charges, namely the positive charge and the negative charge. A body is said to be positively charged when it has excess positive charge, while a body is said to be negatively charged when it has excess negative charges. Then a body is said to be neutral when there is no charge at all. These two charges interact in such a way that unlike charges attract themselves, while like charges repel themselves. Electrostatic law states that unlike charges attract, while like charges repel. Electric charge are tested in the laboratory using an instrument called electroscope. This brings us to talking about electromagnetic force. This is the combination of electric force and magnetic force. It is produced in an ordinary iron rod placed inside a coil of wire through which electric current is passing. We'll be seeing the difference between gravitational force and magnetic force. Gravitational force attracts all objects towards the Earth's surface. Magnetic force attracts only iron objects. Gravitational force acts on things that have mass or weight. Magnetic force acts on objects that contains iron. Gravitational force has a large force field all over the regions of the Earth, while magnetic force has a relatively small force field. Brings us to talking about balanced and unbalanced force. A balanced force are forces that are equal in size and opposite direction, meaning for a force to be balanced, the two sides have to be equal. Examples of balanced force: an object floating in water without sinking, a tug of war game with neither sides winning, doing a headstand without falling, a person standing still or sitting, a jacket hung on a coat hook. That brings us to talking about unbalanced force. Unbalanced force means that the force applied in one direction is greater than the force applied in the opposite direction. Examples of unbalanced force: riding a skateboard, a group of kids doing tug of war with one side winning, a fruit dropping from a tree, an object knocked down by the wind, a moving train. So with this, we've come to the end of the class. Hope you enjoyed watching this video. See you in our next class. Bye.